and thank you for joining us for our second installment in our Lessons Learned from Industry Leaders series. My name is Jason Mills. I'm the Director of Marketing and Communications at KMC Controls, and I want to take this time to welcome and thank each one of you for joining us. On our panel today is KMC's Vice President of Sales, Doug Miller. Doug has been in the HVAC industry for 42 years and has been in the controls and building automation industry for 38 years. Doug is a LEED certified accredited professional. He is CFC certified universal and is NICET level 2 certified. We are also joined by Bob Case, the CEO of Gardiner, a full service HVAC systems and solutions provider. Bob has 47 years of experience in the HVAC controls industry. We're also joined by Ken Loudermilk, who is the Senior Chief Engineer at Titus and has been involved with ASHRAE for 40 years, serving on a number of technical and standards committees, as well as having authored several ASHRAE journal articles. And finally, we're joined by Dave Brinkerhoff, who is a certified industrial hygienist and director of Bay Area operations for Forensic Analytical Consulting Services. For the past 20 years, he's built a broad range of exposure assessment experience, including indoor air quality investigations, building and HVAC system evaluations, evaluating engineering controls, and assessing various physical, chemical, and biological exposures. Today's panelists will be discussing ASHRAE's COVID-19 reopening guidelines. As always, if you have any questions, please feel free to add them to the chat box. We'll do our best to answer those questions at the end of the webinar. And any questions that we can't get to, we'll do our very best to email you those answers as soon as possible. I don't want to take any more time than I need to, so without further ado, I'm going to start us off with our first topic, which I'm going to direct to Dave. Dave, a question we hear a lot is, can a virus travel through my HVAC system, and get me sick?
Thanks, Jason. That's a good question, and I'm going to start by saying the same thing I feel like I say every day. When it comes to COVID, this is a complex and evolving situation. What we think we know today could be totally different tomorrow. So keep that in mind as we have this discussion. When we talk about transmission of COVID, all the data at this point points to the primary route of transmission being respiratory droplets. So I cough or I sneeze, and my droplets leave my body and enter your body. There's at least one study out there that seemed to implicate that HVAC systems could have a role in transmission. There was a study out of China where some folks were at a restaurant and a sick person got a couple other people sick. But if you dig into that a little bit farther, that wasn't really a dilution system like we have in many of our buildings. That was more of a fan coil or a split system that was probably just pushing around air. It wasn't actually diluting and filtering air. So I think that's a pretty poor place to start when looking at the typical systems we have in this country. It's important to remember what an HVAC system typically does. In addition to conditioning the air, it filters the air and it dilutes out contaminants. So my body odor, my CO2 gets diluted out by the system, and we would expect that it would do the same thing with respiratory droplets that are floating around. So I think ultimately the answer is, theoretically, it's possible that I could sneeze and my droplets could make their way through a system and redistribute somewhere else, but I think it's very unlikely, and there's really no studies, no data out there to support that that's a significant way that this virus is moving. I would just add to that one of the things that HVAC can impact is air movement in the building. So depending on how the air travels through a building, that can impact how my droplets move through a building.
Okay. Well, that's certainly a question I know that's always on everybody's mind is what can we do from a building maintenance and a facilities person perspective. And the other question, that we hear a lot is, as a facilities professional, what can I do? What's my role? What can I do to prevent the virus from maybe spreading in the indoor environment from an HVAC perspective? And Ken, that sounds like a question that'd be right up your alley.
Yeah, although it was first thought that the risk of infection by airborne means was minimal, additional analysis, as Dave mentioned, appears to suggest that it may play a more vital role. If this is indeed true, the HVAC system can play a significant role in controlling the indoor spread of the virus. The system should maintain indoor relative humidity levels between 40 and 60%, as this is proven to enhance the virus's susceptibility to treatment and also contributes to maintaining thermal comfort for the space occupants. Now, while ASHRAE guidance suggests that outdoor air delivery be maximized during occupied operational periods and that enhanced filtration levels be considered, the method by which the supply air is distributed in the space is key to the effective removal of aerosol nuclei that is generated there. The key to removing it is basically getting it to the return itself. Can I share my screen real quickly here? And I've got a couple of PowerPoint slides. Okay, you see my screen?
Not yet.
There we go. If you go into the ASHRAE handbook series, the handbook series defines room air distribution as really being a spectrum from fully stratified to fully mixed. The overhead mixing systems that we use mostly in commercial buildings today would qualify as a fully mixed system. Thermal displacement is probably as close as we get with a mechanical system to being fully stratified. And then, of course, there are degrees of stratification that can be accomplished by other systems like underfloor air distribution, for example. But if we look at the two ends of the spectrum, basically the mixed air systems we use today, what we do is that we put air in through in many cases, ceiling-based diffuser. We're going to discharge that air along the surface of the ceiling because there is a capillary effect called the Coanda effect that causes it to remain attached to the ceiling surface. And then it actually comes down into the occupied space itself. Now, we don't want the occupants to really encounter this cold and high velocity air. So what we want the diffuser to do is to create sufficient air movement or entrainment of room air to dissipate those velocities and temperatures quickly before they get down to where the occupants are. In other words, we want the occupants to be treated by secondary air motion within the space. When we do that with the mixed air system, not only do we mix all the heat gains in fairly equally, no matter where they occur in the space, but if we also look at the ventilation or the, we'll say local CO2 concentration, we'll find that the respiratory pathogens that the occupants actually may create in that space are also mixed quite well in the space. And so the level of contaminant at the room level itself is very similar to the level of contamination in the return. On the other end of the spectrum, this is actually referred to as dilution ventilation. The other end of the spectrum, thermal displacement ventilation, we discharge the air in the lower level of the space at a very low velocity and probably a little bit higher temperature. As that air falls, it just moves across the floor in the form of a real thin layer, and only when it contacts convective heat sources in the space, like people, is it pulled up off that floor. It passes up in a one-directional movement through the space and rises to the point where it encounters equally warm air or a obstacle like the ceiling. So basically it all piles up at the upper part of the space. Now your heat gains that are sufficiently removed from the supply air layer, they also entrain air to replenish these plumes that rise above them. But in their case, the air that they're entraining is actually already stratified air, and it doesn't tap that lower level of air that the fresh air that's at the lower part of the room. So when we look at the contamination characteristics or the CO2 characteristics of a room that is served by displacement ventilation, those same convective heat plumes that lift the heat from the body of the occupant and on up to the upper level of the room also serve to pick up any respiratory contaminants that are breathed out, take them to the upper part of the room and allow us to get them out of the room. And of course, the key in removing the pathogens is getting them to the return level where they can be taken out of the room. So the room air distribution is a huge part of what your HVAC system can do for you. Okay?
Ken, would
Continue now.
it be, looking at the picture and the fact that the typical droplets fall to surfaces below, especially if the humidity is in the 40 to 60 range that we're desirous, so that the droplets fall. I think Dave's point about the China thing, that was the only article I read where in Europe they had talked about floor mount or wall mount fan coil units being able to push the virus around because it could get on them. Same is in the situation where you're talking about the air entrainment. Humidity becomes a key factor as far as making the drier the air, the more buoyant the germ or the virus is the way I understand it. Is that the way you do?
Oh yeah, yeah. The drier the air, the more the actual moisture evaporates from the droplet, and as the moisture evaporates, the nuclei or the droplet gets smaller. Smaller it gets, obviously, the more able it is to float around in the atmosphere. So maintaining the humidity is a major part of it. And secondly, creating air patterns in the space that can effectively transport anything that is airborne to the return where we can get it out of the system.
Excellent points. From an industrial hygiene perspective, Dave, anything to add?
No, I think those are all great points. When we talk about aerosols and the droplets coming out of our bodies, there's a wide range of sizes. So big particles are going to tend to not travel very far, tend to hit surfaces rather quickly, and that's where we get concerned about potentially touching surfaces, touching our mouth, contact becoming a route of transmission. But Ken is 100% right. A lot of these particles get very, very small. They're going to stay airborne for longer periods of time, tend to be distributed through buildings and farther distances.
Mm-hmm. Well, yeah, that's one of the things that as we look at the ASHRAE guidelines for reopening, one of the areas, and you mentioned it several times, Ken, in your slides there, you talked about ventilation. And if we've read the guidelines, ASHRAE is recommending that we maximize or go to 100% outside air ventilation in cases where we can, which kind of takes you down the path of a DOAS system, which is 100% outside air. That's certainly going to lead to some penalties from an energy consumption standpoint. And not to pick on you, Ken, but is that an area that you might have some thoughts on?
Well, yeah. I mean, to be honest with you, we talk about increasing the amount of outside air that we bring in. And I think that what follows from that may be even more important is that the more outside air we bring in, the more return air we exhaust. And that's what DOAS systems are really designed to do. If they're using 100% outside air, they exhaust all the return air and they don't recirculate that air to different spaces within the building. Now, you mentioned energy penalties, and there's no question about it. It's more expensive in most cases, or most of the time, to condition outside air than it is to condition recirculated return air. Right. So DOAS systems, when they're used with an all air type system, can have quite an energy penalty involved. However, there are technologies out there like that basically decouple the space cooling, such as chill beams, fan coil units, VRF systems. They complement the use of a DOAS system by reducing the sensible cooling burden on the air handling unit and the central system, which often allows you to reduce the supply airflow rate to the space by even 70% or more. And when you can reduce the amount of outside air, or the amount of air that you have to supply to the space, now it's not nearly as as much energy use as if you were trying to do all of the cooling by air delivery to the space. So now, you know, when you ask the question, what can I do to convert my existing system to a DOAS system? Well, that's not as easy as it might sound, mainly because the existing systems are typically designed to operate with a minimal outdoor airflow rate. And so their tonnage or their capacities itself may not be sufficient to deal with a very high outdoor airflow rate, especially during peak conditions. This is going to be especially true during hot, humid, or cold outdoor air conditions.
Ken, I think one of the things we have to consider is based on your earlier answer about diluting the air and using more outside air to do that, and more exhaust to get rid of the pathogens on a chill beam or VRF system or fan coil type system. That DOAS unit, dedicated outside air system unit, it has probably limited amount of air that it can bring in, as does a typical central system that's sized, because typically we've sized our equipment for an outside air load of how many people are going to be in it.
Right.
And now all of a sudden we want to change from how many people are in there to putting as much outside air in as we can to flush the building. And so we have to look at the size of the exhaust system, and we have to look at the size of the supply system. And as you said, there is a real challenge to see if you're designing a system from scratch. You know, you could say, okay, I'm going to design my system to handle 100% outside air.
Right.
Today, any existing building that we would run into, that is not the way they were designed. And so I think this is where some of the control expertise is going to come in, because we're going to have to try to control this system in the range and maintain comfort in the space. And like you said, as soon as we get to extremes, the unit is incapable of cooling and dehumidifying 100% of hot, humid air, and it's incapable of heating up 0-degree air 100%. So there's going to be some severe limitations on what we can do, even if we didn't worry about the energy costs.
Well, absolutely. You hit the nail on the head there, because there are going to be periods, mild periods in most any climate that, you know, you could probably go to 100% outside air, but there are going to be other periods where you just don't have the capacity to condition that. And so it may be a matter of, I work quite a bit with European companies as well. It may be a matter of we have to accept a little bit of compromise as far as our indoor climate is concerned. They call it adaptive control over there. But again, we may not get the ideal thermal comfort level, but at the same time, what's more important, we've got to come to some compromise there.
And I
Nothing's
think,
quite that easy, is it?
No.
I think one thing that needs to be considered also is that increasing the amount of outdoor air into a building makes a whole lot of sense when the contaminant we're concerned about is inside the building. But what happens if the contaminant is outside of the building? Here in California, wildfires, and when the smoke rolls through the wildfires, one of the strategies is let's reduce the amount of outdoor air, or let's look at positively pressurizing the building to keep that contaminant, the smoke, outside of the building. So if we start to move wholesale to 100% outdoor air systems, that could pose other challenges when we have those types of pollutants.
Well, that was one of the problems that the controls industry faced in the early days of economizers, right? When they first developed economizers, they always assumed that outside air was cleaner and better suited to be conditioned than return air was. And in reality, practice proved out that that wasn't the case, which is the reason we came up with enthalpy sensors and CO2 sensors and a lot of other things that we have today. So that's an excellent point, Dave. And Bob, if I'm sitting here and I'm watching this broadcast today, and I'm a facility manager or I own a building, is there a rule of thumb or a way that they can take a logical approach to determine, okay, if I want to increase my outside air capability, how do I know how much I can actually bring in?
I would take a look at it from the perspective of, if you're willing to pay the energy costs first, I have to say that.
Right.
But if you are, then I would say that you're probably going to want to put humidity controls in the room space, and you're probably going to want to have your dry bulb and humidity control the discharge of the unit. Usually it's either tied to a room sensor or tied to a duct sensor. And if you do that, and you can then modify the programming of the unit to handle as much outside air as you're willing to pay for, and still maintain the temperature and the condition in the space. And Ken brings out a good point. We probably should allow for some leniency in the standard temperature that everybody thought they wanted, in the hope of having a little more fresh air in the space. That is for all of us that aren't in California where there's wildfires and don't want that.
Right.
Yeah, no, it could pose some challenges for sure. Dave or Ken, any other thoughts on that topic?
No.
Okay.
Again, it's a matter of, as Bob said, of you've got to balance everything as to what you can accomplish with your existing system. If you're talking about a new system, knock yourself out and do it the right way. But you got the cards that you're dealt, and you just want to play them the best way you can for your situation.
Yeah.
I think
we look at some of these right now. One of the ways we've tried to save energy and have outside air is a lot of equipment has heat wheels in it.
Mm-hmm.
Well, a heat wheel has a small cross-contamination factor, and so some people, first thing they're doing now is saying, we got to shut off those heat wheels. If you have a fixed plate heat exchanger or some other coil runaround loop or a tilting coil, those things would all be okay, because you're not worried about cross-contamination with them. But that's another thing you got to kind of look at when you're looking at your piece of equipment. So if we shut off the heat wheel, we actually degrade its capability of handling outside air.
Mm-hmm.
Yeah,
that's a very good point.
And disabling the heat wheel is one of the ASHRAE recommendations. The other one is disabling demand control ventilation. That's
Right.
another recommended standard as well, which kind of ties together everything we've talked about. It kind of funnels into the controls end of the world, right? Because ultimately, I have all these devices out there, but they're all operating as these independent, disparate units, and I need a way to tie those all together to make the building function as one. And my ability to do that from that perspective varies greatly depending on the type of facility I have, the type of equipment I have. If I'm in a large built up complex system like a hospital where I have built up air handlers and central plant and individual pieces of equipment, those things are typically highly automated. So I have a lot more flexibility over what I can do with my outside air, with some of my diversity factors than I can with a piece of package equipment that's, sitting on a rooftop someplace, and I may be even limited as to how much I can open the outside air dampers up. So, depending on the type of facility you have and where you are, going to limit you and or benefit you depending on which side of the coin you happen to be on. And what I would suggest for a lot of people that are watching out there, I would like to think that this is going to be the first and only time we go through this. But on the outside chance that it's not, maybe it makes good sense to sit down and develop what I'm going to call an epidemic mode or a disaster mode or an isolation mode or a oh crap mode or something, right? Where something's happened and I need to be able to, with a command or at least a single command, be able to make all these changes in my system that are going to effectively put me in that mode I want to be in, whether that's negative pressure, 100% outside air, isolation, those type of things. Those are things I think we as automation professionals can set that up in software so that the owners, the building operators can simply go to their workstation, go into the epidemic mode, and then put the system the way they need it. Now, the caution I would have there is every system is going to be different. And I don't think there's going to be a canned one-size-fits-all epidemic mode that's going to work for everybody. I think it's something that's going to have to be evaluated by building personnel and or if you need help from an outside contractor, but you're going to have to determine what you can and can't do first before you start to go down that path of, okay, this is what I want my system to do in this scenario.
Right.
That's my 2 cents worth on that. I don't know if you guys have any thoughts on that or not.
I
That's a
think
really good point, and a lot of good points, put it that way. And what we've witnessed as we've monitored some buildings is sometimes some of the steps that the maintenance man thinks are good are actually counter to what you want them to do. So it's good to have a trained expert who knows how to do that, set up a program, and that would be one of the advantages if you had a pandemic or epidemic mode that you could switch to. Somebody could have thought through that, and then your facility guy just has to say switch to that, as opposed to him coming up with something, because we've seen some really interesting situations since we've got this. We are fortunate. We have about 300 buildings that we monitor. And so we were able to take a look at them and see some situations, and we're going, I just don't understand. So we talked to the maintenance guy and he explains himself, but he didn't quite take into consideration the whole system and was doing things that were counterproductive.
Yeah, it'd be great to be able to make some of these decisions ahead of time rather than trying to make them on the fly with, limited staff and everything else. It occurs to me that, a pandemic setting would be great, as would a wildfire setting if you're in California. The challenge, they're opposite settings. So what happens if you have a wildfire during a pandemic?
Well, another thing, if we remember back to the SARS situation, so much work was done on the vaccine, and then all of a sudden hot weather got here and the pandemic went away. So we stopped. And fortunately, there's a lot of research there that has been picked up again now. But it's always easier to deal with it, or not deal with it, really deal with something else when the pandemic goes away.
Right.
And then get awakened later.
Yeah, I mean, at the end of the day, we all have to understand that we're going to be in a risk situation no matter what. It's what can we do to mitigate that risk and realize that, you have to determine what do I really, really need versus, what it'd be nice to have. And I think those are the decisions you got to make as a facility professional. I know on the service side of things, Bob, you're responsible obviously for a very large service organization. And I'm sure that's presented its own set of challenges for you folks as well as trying to run HVAC service right during this pandemic. Have you discovered or come up with any best practices, best procedures? And on the other side of that coin is there a point which you just say, you know what, we got to walk away from this one?
Well, we've given our service techs some guidelines, and the very first thing is even the dispatchers ask the client if there's any known coronaviruses in the building that we're being asked to take care of. We take care of a lot of hospitals, so we've worked with some of them. And Ken, you'd get a kick out of this. One of the 3 big hospital associations here, they told us we didn't have to worry about any special danger on the rooftop units because there would be no coronavirus that could get to them. And this is early on, you know. So as I think, Dave, you started this by saying this is an evolving subject and it keeps changing. And let's face it, the experts don't have an answer yet. And so we're all trying to work with our best estimates, our best science that we can. So we ask about that, and we try to keep our guys out of the areas of known infection. So we're lucky that we work on mainly the bigger pieces of equipment. So the chillers that are outside or the chillers that are in the equipment room. We don't work like a lot of nursing homes have through the wall air conditioners. Typically, we don't work on that type of equipment, so we haven't had to do it. But we really try to limit our time where we're in the client space where there could be any kind of contamination. We try to find exits and entrances to the areas we have to go that are the closest to the outside. We have our people wear face covering, and if they're in any risk at all, then they wear an N95 surgical mask as opposed to their regular cloth mask. We actually encourage them at any healthcare facility or nursing home to use their N95 masks. And then we joke about them carrying a 6-foot stick to keep people away from them by 6 feet. But I mean, we tell the people, give our guys space to work. Please don't hover over them. They wear rubber nitrile gloves when working, especially if hand washing isn't possible, and they dispose of those before they leave the site. Frequent hand washing, sanitation encouraged. We provide hand sanitizers for their trucks and for them to carry with them. Avoid sharing tools when possible. Clean and sanitize your tools with Virex when you're finished with the job. Keep your vehicle clean and sanitized with Virex. We have everybody in the whole organization self-monitoring their symptoms daily and absolutely encourage them to stay home if sick. And then we suggest that they change their uniform outside of their house before they come in. At the end of the day, we are constantly empowering our techs to protect themselves, because if they don't protect themselves, they can't help the clients. So and if they have any question, to call us and we'll talk to the client and try to rectify things. We've been very fortunate so far that they have stayed healthy, and we've been able to keep everybody up and running.
Has there been any cases that you've just had to, say, you know what, we can't do this, we have to walk away from one? Have you experienced anything like that?
We had one nursing home where their 6 maintenance guys all came down with the coronavirus. And we suggested to those people that we would work on the outside unit, but we didn't want to go inside their building, as we didn't know where the infection was, and that they probably need somebody like Dave to go in and try to have his people figure out what's going on. That they eventually, that lasted for about 3 weeks, and then the incidence rate dropped, and some of their facilities guys came back, and we were then able to resume working there.
Okay.
Yeah, I think that sounds great, Bob, and that's really consistent with the framework OSHA has established for protecting people. They've got a risk matrix, and for a lot of what you guys are doing, it's fairly low risk. It's keep your distance, wash your hands, all those things that you just mentioned. Where we get into a little bit of complexity is, what do we do with people that are changing filters or working inside of systems where they have contact potentially with the airstream? And the real answer is we just don't know what the risk is. ASHRAE has come out and said, if you're talking about a hospital and you're going to be changing filters, you should be wearing an N95 at minimum. You should be taking contact precautions, right? So gloves and eye protection, that kind of stuff. For your typical office building or commercial building, the risk is probably lower, but we just don't have the data to say that there is no risk. So we tend to default to the conservative and say, these people are trained to wear respirators anyway, let's go ahead and put them into that. And then where it gets really complicated is, what do you do when you're on the roof of a hospital, right? And you may have sick patients in an isolation ward that is exhausting to the roof, and that air is probably not filtered. That just adds a whole another level of complexity. How do we deal with that? And the research just hasn't been done. We know that people work on roofs all the time, and during flu season, we haven't seen any outbreaks of flu in roofers who were on a roof of a hospital, but maybe we just weren't looking for it. We don't know. So I think taking a conservative approach at this point probably makes sense.
Mm-hmm. Yeah, and that's a good point. And I think that comes back to, there's no substitute for really understanding the facility as well as you can. Your example of rooftop exhaust in a hospital is perfect, because you go up on a hospital roof and there's multiple exhaust fans up there. And not every one of them is coming out of a COVID ICU. One of them is coming from the kitchen, right? One of them's coming. And if I'm an outside contractor, I'd like to have a facilities guy up there with me to at least point to that one and say, don't go near that one. That's the one coming out of the COVID space. So I think it points to the fact, the better relationship we can develop with the facilities personnel, the safer we can be ourselves as well. The other question that comes up a lot, and I hear this terminology bounced around a lot. I'd like to explore it just a little bit. We've got about 5 minutes left. Let's talk about ultraviolet lighting and UVGI treatment. That's an area that I think you've got some expertise in. Ken, could you share your thoughts with us on that?
Well, I've learned a lot about it in the last month or so. ASHRAE specifically recommends the use of UVGI treatment during this pandemic time. There's basically two types of UVG. Well, there's three really, but induct UVGI is what most of us are familiar with in the HVAC industry, where we place the ultraviolet lamps actually on the upstream and downstream side of the coils, hoping to kill any mold or bacteria or virus that might be there on the surface. And it's more of a disinfection type strategy that we're applying there. Although it may help deactivate the nuclei that is passing through the air handling unit, it probably does nothing to affect the airborne aerosol within the occupied space, or very little. What does seem to work very well in the space is what they refer to as upper room UVGI. And basically that involves placing these UVC fixtures or lamps that transmit 200 to 280 nanometer wavelength ultraviolet light horizontally across the upper level of the space to irradiate the portion that is not occupied. And that way, if we can get the contaminants to that zone, that upper zone, and keep them there long enough, give enough exposure time, the UVC light seems to be extremely effective at deactivating the virus. When I say deactivating, making it to where it cannot reproduce. It doesn't kill it per se, but it's kind of like me, that I'm harmless these days. But so Again, it's been proven very, very efficient. But again, that's where our HVAC system can come in as well, because the type of room air distribution that we do can significantly enhance the effectiveness of the UVGI upper room method. Displacement ventilation obviously is a very good way to go, because basically it creates a unidirectional air pattern through the space that lifts airborne contaminants, respiratory contaminants that are almost like gases, basically, to the upper level of the space, and then basically confines them there until we get a chance to get them out. So the residency time in the upper part of the space is quite high, which really complements the UVGI upper room type treatment. In addition to that, if you don't use displacement ventilation, there are some other types of supply air outlets, high induction, low throw type diffusers, which again tend to suspend those particles in the upper part of the room long enough to allow well, not only suspend them, but induce them up to the upper part of the room and suspend them long enough for the UVGI treatment to be effective.
Okay.
And I've read, I believe I've read, correct me if I'm wrong, but if UV is only effective if you can get the velocity below 500 feet per minute to stop the growth. Is that similar to
Well,
what?
it probably is, obviously, when you're talking about 500 feet per minute. I've seen that too as a rule of thumb, but that's in the air handling unit. That's when it's in duct. Obviously, when it's in the room, it's not going to be 500 feet a minute. It's going to be very low velocity in the room. So I think that's why it's not that the upper room UVGI is better. It's the fact that the exposure times are much, much higher. Of course, when you use the upper room, you know, people may be thinking, well, does that not create a problem as far as the health of the individuals in the room? Namely, you really don't want to subject people's eyes to the UV light itself. But most of these fixtures either come with some sort of a baffle to make sure that the light is very directive in a horizontal pattern. You certainly want to make sure you mount the fixtures above the occupied level of the space. In other words, probably 7 to 8 feet above the floor. And if you do that, then there's really not much threat as far as any damage to the eyes. And they've proven, really, even if you do get damage to the eyes, it's more just an irritation. It's not a long-term effect that you're going to have, not with this UVC ultraviolet rays. Some of the other bandwidths of ultraviolet, yes, that can be a big problem. So,
Doug, two other places I've heard the UV used. We've used it for many years inside air handlers, as Ken alluded, to actually point towards the coil and to keep films off the coil and anything that is growing on the coil. And then, Ken, I don't know if you've read about this, where they actually in off hours will put in UV, kind of like a vertical tower, put it in a space to kill, but that's when nobody's there.
yeah, when it's unoccupied, yeah, that's, again, it's a form of what they would refer to as UV sterilization. And again, it's very effective. I read some articles where they were using it to disinfect buses and things like that in Japan. So it's very effective, but it's not something you'd want to do when the people are there.
Right. Yeah, UV has a long history, particularly the upper room UV lights. You know, I would just add that it's important to remember, you know, we've talked about a lot of things today, and none of these things are a magic bullet, right? Ultimately, you know, this is a public health problem, and it's the public that's going to solve that problem. You know, any new device, or I see things about, you know, fog your building or apply these coatings to your building in the last 3 months. All those things may be important tools in the toolbox, maybe, but fundamentally, the control of this thing is keep your distance, practice good hand hygiene, don't go to work if you're sick, limit occupancy of buildings. The combination of all of those different tools is, I think, what's going to really do the most to slow down the spread of this disease.
One thing that surprises me is I have read very little that has been focused on K-12 schools. Now, I know K-12 schools are always budget strapped, no question about that. But and that the kids don't seem to develop symptoms, but that doesn't mean that there's not passage of the pathogens from kid to kid, and then they take them home, and you've got 20, 25 kids cooped up in a room for that period of time. It'll be interesting to see what comes out of this as far as reform on school spending. Fortunately, the school year is mostly during mild or cold periods. So, but in any case, that's one that's interesting to me. But I've always been a little puzzled by how many resources we really dedicate to making sure that our schools are a good, healthy environment, even in non-pandemic times. So I'll get off my soapbox.
We're working with a lot of schools right now who are absolutely horrified at what it's going to take, because so far in the state of Ohio, they haven't said what the conditions are. And to my knowledge, CDC hasn't come out with anything. But if you take a 40-person school bus and you go 6-foot distancing, that goes to 10 people.
Right.
And then you need to disinfect. So I know the schools have gone this far. They've tried to figure out if we can only put 10 people on a bus, then we have to bring it back, disinfect it, and send it out again. We'll be spending all day just to get the students there. And then we're going to have a 6-foot distancing in the classroom. It's going to be really, really, really challenging. And so that is a real hot topic if you talk to any superintendent.
Oh, it's going to take a lot of trailers. And again, most of the schools that I've been involved with, you're talking maybe 20, maybe 30 to 32 square feet per person in the classroom. You're not going to do much 6-foot distancing.
Yeah, it's a topic you could almost do a webinar on itself. No, the school thing is actually near and dear to my heart as well. You mentioned school buses, Bob. My wife is a school bus driver, so I truly have an appreciation for that. And as we like to call them, the little petri dishes, because especially when you get in the elementary school, they don't understand hygiene. They really don't. It's not their forte. And she's been in a pretty regular habit in flu season of, she takes her own Clorox wipes in and wears gloves and wipes her bus down and sanitizes it as best she can. But it's certainly going to present another challenge to the K-12 districts as they open back up.
As the parent of a 5 and 7-year-old, I can confirm that they don't understand.
Well, no. You don't want them to just stay at home, do you?
No, that's been happening to a lot of people since mid-March, and I think there's a lot of parents out there right now that are more than ready for the new school year to start.
Right.
Anything that we haven't talked about, Dave, you've got a lot of expertise here from the industrial hygiene perspective, and your world is a little different than ours. As far as sanitizing and things we can do. Any other thoughts you want to share with us?
Yeah, our kind of where we're at right now with a lot of our clients is how do we return to work? How do we put people back in the building? And so all of these things are coming up as questions. What do we do with the HVAC system? Depends what kind of system you got. Can we, I heard one facility manager say, yeah, we're upgrading all of our filtration to MERV 14. Well, you're going to do that on that little package unit on your roof that's 30 years old. You know, it's very dependent on what you're able to do with your system. I think wholesale upgrading filtration is a challenge. You might get as much bang for a buck just making sure your filters fit really well, or maybe you tape them in so that you limit bypass. But a lot of the kind of big picture stuff it's pretty common sense. You know, we look at a building and go, how do we treat that person in their office? Well, that office is their personal space. That person's going to be responsible for cleaning it, keeping people out of their personal space. It gets a little more challenging, you know, when you start to talk about conference rooms and break rooms, and you know, how many people can put into a conference room safely now. It used to be 10. Today, I don't know, 5. You know, it kind of depends. So a lot of common sense approaches, but it really kind of, to me, comes down to those basic things. Keep your distance, good hygiene, don't go to work if you're sick, and then, you know, use what you have at your disposal, your HVAC system, if you've got good control of it, or maybe some of these other technologies, if they're effective, to supplement those basic practices.
Mm-hmm. I know I think the ASHRAE recommendation was MERV 13 or better filter-wise, which again can present its own set of problems. You know, if you're using, you know, glass packs or real low efficiency filters, you start slapping MERV 13s, if they'll even fit, okay, if you put them in, you know, now you start looking at, can my air handler overcome that static, and can I push air, and will I lose my air exchange per hour? And you know, and you get into the newer equipment with the ECM motors, and ECM motors, and I'm not telling you anything you don't already know, Bob, the ECM motors are even more sensitive to static. You know, they have a high tolerance for them, and a lot of people have burned them up by putting in too big of a filter.
I think they're one of the things that we've also seen is the use of electrostatic filters to charge particles so that they gather together, and then you can use more standard type filtration, but you have to change your filters a lot more often.
Mm-hmm. Yeah, it's probably something you see on the service side, I would imagine, more than anything.
Right.
Well, that's another big thing on the MERV 13 too. If you're replacing MERV 8 filters with a MERV 13, if the filter is far more efficient, you're going to be changing it far more often too. So, you know, certainly you want to consider if you go to a MERV 13 or greater, you want to make sure you've got some sort of a pre-filter too that'll take out the big chunks before it gets there.
So I think what we'll do is we'll just wrap it up and call this a wrap. I do thank, gentlemen, I thank each of you for taking the time to be with us today. And it's been a good session. We've fostered some great discussion between the 4 of us. Hopefully it's been informative for the people that have been listening in out there. I think we've covered some good topics. And I just wish us all safety and health, and continue to stay healthy out there and do the best we can during this unusual time.
Thank you, Doug.
Thank you, Doug.
All right.
Thanks, Doug.
Thank you, gentlemen.